Buenas tardes. Let's see who's on. It looks like people watch the Monday stream. And I'm just checking if anybody is with us, or I'm going to be flying solo again, except for Ricardo, who pops in. It's just me. Okay. Well, seeing that most of you watched the last stream, that's a positive, that's a plus. So I am going to continue where I left off, which was pretty much the end of the notes. And what I left you with, we had drawn that. Oh, let me get the file that we did together. Right, this is the one. So I'd asked you to calculate the risk premium for each of those different asset classes. And if you didn't do it, you can do it now. So when I ask you questions, if you're watching the recording, just pause the recording and attempt the problem and then come back in. So what I'm going to do to calculate the risk premium, as I did last class, and I'm going to use this notation so I want the arithmetic mean of the asset class. I can call it I minus the risk-free treasury bills. Okay, so risk-free, this is not risk-free, but well, I guess it is. It's returned to the risk-free asset. The F stands for the risk-free. And I don't put a bar on it for a reason. The assumption is, in addition to saying this is risk-free, in other words, sigma, even though there's obviously a standard deviation here, in our methods, we're going to assume that the risk-free asset represented by T-bills has a standard deviation of 0, and the return on the risk-free asset is a constant, so there's no variation. And I better just write that. Let me write that in words. So I don't have to put a bar on it because it's not an average. It's just the same number. It's constant. That's another way of saying that the standard deviation is 0. Okay. So using the data I have here, this would be my RI, and this one is the RF. Or I'll say R bar. Sorry, it's my iPad standing up. And then this one is RF. All right, so making the subtractions all the way down. $7.9. I have to reposition my iPad because I'm not comfortable here. Let me know if I make a mistake or you get a different answer. Okay, so those are the risk premiums. And as you look, the highest risk premium, the greatest incentive in terms of the required, meeting the required or expected return would be for investors investing in small company stocks with a risk premium of 12.6. Second would be the large company stocks risk premium, and then the less risky assets of long-term corporate bonds or long-term government bonds. They're about the same. They're different, but I wouldn't say that's significantly different. But anyway, we'd have to check. All right, so that's that. That's what I want to say about that. Let's see if anybody showed up to ask questions. Gabriela, Alexa, hello. Do you have any questions for me? So you should have finished the review of statistics for what I'm going to do next. I just fixed one document in the platform in Moodle that wasn't coming up properly. I had put a wrong, incorrect document in there. Let me see. I'm going to verify and clarify which one I changed. Actually, I should note that it's changed in Moodle, right? Let me put I'll put a new tag on it. So in fact, in Moodle, this is not opening. In Moodle, this is the document we talked about. I don't know what I was going to say. Okay, in Moodle, I'm going to put in. Oh yeah, okay, I just put it in. So it should be risk and return formulas document. I talk about it in the video, but I didn't have it in Moodle, so I hope that's not confusing. I haven't heard any complaints, but that doesn't mean it wasn't confusing. Sometimes students don't know what to ask, right? I'm gonna have to flip this over. I'm checking to see if you guys have any questions for me. I'm sorry, Gabriela. Yes, they will be. I wanted to finish them on Tuesday, but then I had some interruptions. I mean, Monday. So after this class, I will do my best to post them. All right. And yeah, I also have to put up new Connect questions for you today and put up the rest of the notes for this unit. I have a lot to do. Okay, I'm just, I gotta flip this over. You saw that, but I had to flip this over. And any other questions for me? I know your tests are important, but I have to give myself time to grade them. So, well, last time I gave them to you right away because they were all multiple choice, and this one clearly was not. So it just takes me more time. All right, so you can see the platform, and am I in our course? So in Unit 5, I have to show you your view or it gets confusing. Okay, so you have here, so I right under where it says, no, not this one, risk and return formulas, this one. I just changed it because it wasn't the right document. Okay, so these are the formulas I want you to know. This is the type of data we're going to focus on, financial data. And what I just discussed is where these numbers come from. Okay, so that's what I talked about on Monday, how we calculate those values. And in this document, I'm showing you the formulas as though this one is X and this one. So S&P 500 is X and the BCE is Y. And why did I do it like that? Why didn't I make BCE Y and S&P 500 X? Does anybody know? Sorry, Gabriela, I'm reading your comment. Don't be nervous. I have your best interest at heart. So follow my lead. Okay, so my question was, is there a reason why S&P 500 is X and BCE is Y? Do you know? Did you finish the review of statistics? So I gave you the review of statistics so then I can use those tools to apply to financial data. Last class I discussed how we can compute these returns. And I have all the statistics that I want here. Okay, so nobody knows why X is S&P 500 and BCE is Y. All right, so I'll make sure I mention that. And then here is another way to see the data and the statistics that are equivalent to those above. No comments? Okay, well, I'm going to leave it because I feel like you didn't finish the statistics review, so you need to finish that. And that's the kind of thing you should understand and what I'm doing here. So Y is S&P 500X, BCE Y. Can you compute all these statistics with your calculator very simply? And that was the discussion. And the difference between this kind of data and data presented like this. Okay. So that's what you need to resolve with your review of statistics. Talked about all of this. So what I did is I don't know why it's making me do that. So I updated that document. The other document for risk and return formulas is this one. And it's comparable. All I've done here is to use the same values for this example, same variables, but all I've done is recast it with financial notation. So RM for the market returns and RI for the firm returns. So in here, this is the notation I use. Now you don't have to, I mean, you can put all these formula on your, well, anyway, you don't have to memorize these per se, but you should understand how to use them, right? The most important thing is Well, I mean, it's all important. The most important thing is all of it. Okay, these are the formulas you need for statistics. They're for one variable and the relationship between the two variables. And that's what I talk about in the videos. Okay, so I have the sense you guys didn't watch those. So watch those, and I'm going to get on with the next, well, not right now, but I'm going to get on with the next set of notes. So the next set of notes are the slides. Oh, that's slides. So I have to open the, I have to suppress that. So I have to open the next set of slides. All right, so give me a moment. Open that for you. All right, so you should see that there are the notes here by one slide or two slides per page. And this is what we're going to talk about next. Okay. Let me open those on my side here. So you can have them, yeah, one slide per page or two. So what are we doing? Let's get back to our purpose. So I had you review statistics. We're going to use statistics to help us estimate the appropriate risk-adjusted rate of return. That is our objective. Okay, so I just showed you on Monday how we calculate returns using some statistics. We use the average, right? The geometric average, and then I talked about different asset classes and introduced the idea of a risk-free rate in the T-bill as compared to other returns, and talked about the risk premium, that little bit that investors need to be hopeful of in terms of return to be incentivized to take on greater risk. The fact that riskier assets or riskier asset classes have accompanying, well, they have a higher standard deviation, but they also have a higher rate of return, is a general pattern that we see. And we want to exploit that pattern to help us to estimate that required rate of return for particular firms. That's what we want to do. All right, so let's see. Well, the goal is to use the capital asset pricing model to do that. So I'm going to teach you about the capital asset pricing model. Now, there's other ways to estimate the required rate of return that a firm will use in evaluations of projects, in alternative investment opportunities. But we're going to learn, in this class, you're going to learn the basics of the capital asset pricing model. So, in summary here, to make good or value maximizing financial decisions, one must understand the relationship between risk and return. We accept the notion that investors like returns and they dislike risk. We're going to use the measure of expected return as a proxy for return. The expected return is like the average return, right? An arithmetic average return. Now, in the review of statistics, I introduced data that are historical and data that are ex ante or predictive with a distribution. And that's what I'm going to look at right now, where we say in general, the expected return is the weighted average of the distributions of possible returns in the future. In terms of the risk, we're going to use the variance of those returns as a measure of risk, a measure of the dispersion of the distribution of possible returns in the future. All right, so that's why we need statistics, okay? To do any of this, we need statistics. So as I introduce to you, let's make sure you can see what I see. So if you did the statistics review, you'll know how to calculate the expected return with this data. There are 3 states of the economy. Now, in reality, there's infinitely many possibilities, but information was used on projections of the economy using financial statements and prediction models. We also consider the returns to a stock. And let's say we settled on just 3 states of the world, okay? So there could be that we are in a low growth state of the economy, a medium type growth state of the economy in terms of GNP, or a higher growth rate or higher growth in the productivity of the economy, okay, as measured for the economy. So the greatest chance is given to the middle one. We have to use a weighted average then to calculate the expected return, not the arithmetic average where you just add them up and divide by 3. Okay, so this notation at this point, it shouldn't be confusing to you, because I did review this in the statistics review. Just to note, this is a proper allocation or distribution because the total of the weights is 1. So to calculate the expected return when the data are like this, you just multiply each of the possible outcomes by their weight and you sum them. So the expected return for this stock from XYZ company is 15%. And I use the expected return, or I can use the symbol mu, because I'm treating this distribution as though it represents all possible outcomes. In other words, it's the population distribution. So I'm going to use the symbol of the population mean, mu. So don't take it lightly about the statistics review. Like, you really need that for this unit, okay? So if you haven't done it, go back and review it. What about the standard deviation of returns? This is the formula. We start with the variance. The variance is the average of the squared deviations. So we say the weighted average of squared deviations from the mean. So this is just more wordy, right? There's just more symbols when I use the R's in my equations, but it's the equivalent of the variance formula that you're used to, where the variance, I'll write the standard deviation because you're more familiar with that. No, I did that wrong. Sorry. Do that again. Okay, so it's the average of the square deviations from the mean with the square root around it to get the standard deviation. So here's how you get the variance, and then you take the square root of it to get the standard deviation. Again, I'm using the Greek letters because the Greek letters are what I use when I'm dealing with the population, and the data that I was given, it looks like the population data. So I go through in these notes the calculation, the computations, but let me show you, even though I mentioned in the statistics review, you cannot use your TIBA2 plus to make this calculation, you actually can, all right? So I'm gonna show you how to do that. Here are the final results. So the mu was 15% and the sigma is 14.14. So it's quite spread out relative to its mean. And we're going to interpret that in a moment. So let me show you how we can get this easily out of our calculator. Let me get the initial data, the set here. Oh, and I'm going to do this on a split view, right? With the calculator. There we go. All right, so to enter this data into your calculator to get the answer, and this is for data that's ex ante data, okay? Before we see the data, this is predictive data. Kind of have a frog in my throat, sorry. So I need to use the stat and data keys in blue. Let's go into the data key, and I see there's something there, so I need to clear it. Second, clear work. And this is where I'm going to put my data. My probabilities, notice I've entered them as a decimal to maybe make it less confusing, because my units here are percentage. So let's leave these as decimals and these as percentage and interpret our results as a percentage, right? Because these are the weights and this is the value or the variable of interest. It's as a unit of percent, and that's how we'll interpret the results. Okay, so let's put in as X I'm going to enter P, the probability as X and the return as Y. And then I can find my results in the stat, and I'll show you how. Okay, so let's put X as 0.25, enter. And now I put the Y. It's going to be 5 negative, enter. Let's put in the second pair as 0.5 for the probability, and the Y is 15. And then for the third case, the probability is 0.25, and then its pair is 35%. So I have all my data in there, and I'm not going to get a correlation. What I want to do is get the I want to get the weighted mean, right? Now to get the weighted mean, I hit second stat, and this is going to give me the results of the linear prediction. It'll give me the how many observations there were. It'll give me the average, which is meaningless, right? I don't want the average of the probabilities, and I don't care about the standard deviation, and I don't care about the population standard deviation. I don't care about any of these, and I don't care about the linear relationship. What I'm interested in, so there's all these statistics if I keep on scrolling. And there's this one. What does that look like? Does that look familiar? That is the multiplication of X and Y summed up. That's what that means. So I can use that to give myself the mean. So if I multiply X and Y, it's the same as multiplying P, K, R, K, which is like the formula. So that's all I have to do. Now the faster way to get that rather than scrolling through is just go backwards. So let me clear that for a second. So if I say second stat, I can go backwards. So I'm going to scroll up and it's right there. Okay, it's at the end of all the statistics. So that's how I can get that. And then to get the weighted standard deviation, now I'm thinking if I can do that as easily. Any questions about that calculation? So this is going to be 15%. And that's what I got in the notes. Right? To get the weighted standard deviation, I honestly don't have a quick way to do that, but you can get the weighted mean. I'm going to think about if you can do this weighted standard deviation as well. I have to think back to my, oops. My statistics tricks. Okay, so I'll put that on my list of things I need to do. All right, so so we left off here. I'm sure there's a way to do it. I just have to introduce a new formula. So let's do that next class, if I figure it out. All right, so If you can, and all you have is the mean, then you will have to do this table, right? So this table just means so you have to take the deviation from the mean, square it, and put the weight in front of it and sum them up. So what I've done here, where this expected return is 15%, which I end up doing everything in decimals here. So keep clear of that. So I'm going to do everything in decimals. If I take 0.25 minus 0.15, I get 0.1. Sorry, that's not right. Let me put this column in to see it better. Let's put this column in here. I'm trying to make this as straightforward as possible. So if this is my RK, so RK minus 0.15, so this is negative 5% minus negative 15% is negative 0.2%, I mean negative 2%, so then you square it and you get this. So that's how I did that. 15% minus 15% is 0, squared is still 0, and then 0.35 minus 0.15 is 0.2, and you square it and you get 0.04. Then you have to take this amount and multiply it by this column to get this here. So let's do that. So 0.04 times 0.25 is a simple is it 0.01? Yeah, so this is 0.01. Actually, let me do the math. So this is 0.25 times 0.04, and that gives you, let me move them over a bit. Right, and then this one is going to be 0, and this is also going to be 0.01. They're the same. And so when you sum them, you get 0.02. So what you found out with the information that you were given is that the average return was 15%, but the variance is 0.02, or taking the square root, the standard deviation is 14.14%. Questions? It's driving me crazy, this thing. Oh, no. See, it detaches everything. Can't. No. I have to use two hands. Nope. They changed everything in the last update. All right, did I do it? Oh, I did it. I should use the one slide per page. Anyway, okay. So before I get to this next piece where we're going to combine assets to create a portfolio of assets, I haven't talked about the statistics regarding combining. yet. So this is the new stuff, all right? This is the new material. So let's see what we can do here. So these are going to be new statistics, just a few of them. And you can lean on what you've already learned to follow along. So we're just going to imagine two assets, A and B. And you have information, very simple information, about two possible states of the economy. Either there's going to be a boom or a bust. With that information, what's the expected return for asset A? What's the expected return for asset B? Well, we have to compute a weighted average. And that means multiplying P by asset A's return and adding to P by asset A's return in the bust state. And when you do that, you get 6%. So you got to practice that. And then do the same for B. 0.4 times negative 20% and 0.6 times positive 25%. All right, so just those are the calculations. You get 6% for asset A and 7% for asset B. Now, looking at these two assets, what can you say about them? What do you see in terms of their returns? So always take a moment to observe. No comments? Well, you see, the negatives are reversed. When asset A does well with 30% return, asset B does relatively poorly, right? Negative 20% return. So there's a loss. For every dollar invested, they lose 20%. They didn't make anything. And for asset, and for in the bust economy, asset A does poorly and asset B does relatively well. Okay, so these assets are negatively correlated. When one does well, the other one does poorly, and vice versa. So how will that affect things? Well, if I want to look at these two independently, that's one thing. And I want to compare them. Right now, it looks like asset B has a higher expected return, but that's not enough information. I learned that there's volatility, and I have to figure that into the equation, right? I have to think about, well, how certain am I to get that 7%? So let's see. That means that we have to calculate the standard deviation of each of these assets. So let's do that. So I'm just going to walk through this, and you can verify all the calculations on your own. Same data set. The variance on asset A is the average of the weighted average of the square deviations from the mean of 6%. And when we do that, we get a variance of 0.0384. And for asset B, doing the same thing using its expected return of 7% is a higher variance than for A. So, well, what do we see? Calculating the standard deviation, returning our numbers to percentages, we see that although B has a higher return, it also has a higher risk, okay? And it's not necessarily always the case, but there is a general pattern that you'll see that higher risk, higher return, expected return. So how do I know which one I should pick if I had to pick between the two of them? What should I do? How do I look at expected return but include risk consideration? So which asset is preferred? Now, the first answer, or we begin with considering that it depends. It depends what type of investor you are. A risk-averse investor will want the less risky asset. The risk-loving investor will look at the riskier or consider the riskier asset. All right, that's what I explain here. So risk-averse investors, when presented with two securities with comparable returns, will choose the lower risk security. Risk-loving investors, when presented with two securities with comparable returns, will choose the higher risk security. So what is comparable returns? Well, this one is 6% and that one's 7%. Some people might think that's comparable, but there still is a difference, so 1% there. So let's see if we can clear up the fact that these are not exactly the same. How can I take things into account? The way I do that is with a measure of the coefficient of variation. The coefficient of variation, or the CV, is computed using both the expected return, the risk, and the way that we compute it is we take the risk, which is the, what we don't like, and we spread it out over the return. So we're trying to figure out, is the risk worth the benefit? Is that how I say it? Is the benefit worth the risk? So is the benefit worth the risk, or I'm going to divide it by risk by benefit. So I'm going to divide in a way saying per unit of benefit, what's the risk? That's what I do when I calculate this. So I take my numbers, 19.6% as a decimal, and I divide by 0.06, the expected return, and I get this, 3.27. So that's the risk per unit of benefit, the return. And then here, for standard deviation B, this is the risk divided by per unit of benefit is 3.14. So, I've collapsed these numbers into single statistic. So this is a new statistic that you need to know. You can add it to your list. Coefficient of variation. And what does it tell us? Which one's riskier? Asset A is riskier, higher number per unit of benefit. So it's going to be B that is preferred by risk-averse investors, right? And then risk-loving investors would choose the opposite, A over B. So this is a measure of relative standard deviations, a standardized measure of dispersion. Think about it as the risk by benefit. Okay. No questions for me? I'm going to watch along. Make sure I'm not missing anything because I don't see comments. I know you're there. Okay. All right. So what did we find out? So A was preferred to B only for risk-loving investors. Otherwise, B should be preferred to A, where B was, so I'm going to take this data down with me. B had a higher return, but also a higher risk. But when you put it together, it's worth it. Risk is worth it. Oh, let's see if I can. Nope. No mercy here. Let's see if I can. That's crazy. Okay, I'm just going to recopy these. All right. So what if I wanted to hold both those assets instead of just picking between them? In doing so, what I'm creating is called a well-diversified, well, it's a diversified portfolio, let's say well. And I'm just going to look at two at a time, and then I'm going to look at the case of more than two at a time. Because in fact, when you hold many assets, well, in this case, risky assets like stock, when you hold them together, you often hold more than one or two. Okay, so we need to look at the general case of holding more, but we start with two just to familiarize ourselves with the statistics involved. Now, you may or may not have learned the statistics for two variables, but now you're going to learn it, okay? So these formulas are going to look familiar. If you have many assets or securities that you're combining to get a return, you will use the weighted average to find the expected return of all those securities. Well, what would the weight be in this case? If I don't have data, the weight up here for this data was the probability of the outcome. The weight here is how much of the asset I'm going to have in my investment portfolio. So let's look at just two assets at a time. And I'm going to invest 50% in the A and 50% in B. And I'm going to use the data that we already saw. Let's see if I can do it here. I can do it. It's going to work now. No, I'm not sure what I'm doing wrong. Let me copy them out anyway. So I want so this is what we just worked with. Okay. So this is my information that I have, and there's just two assets that I'm combining, and I'm going to combine them equally. I'm going to, in other words, so if I invest, for example, well, let me get rid of this before I continue. So if I invest $1,000, that means 500 will go in A and 500 will go in B, if that makes it clearer. All right, so, but I don't need to put the dollar signs in right now. I only want to stick with looking per dollar, right? Just our calculations per dollar. So what I do is I put the weight of 50% on the expected return of A. And the weight of and the weight of 50% on the expected return of B. I could change that, but it's just simple to get the point across. So what would be the expected return for P? The P represents portfolio. You can use your calculator to compute this very easily. We can do what we did last time. Let's get into our data set, second data, and clear it, second clear work, and enter in pairs. The X would be the weight, so 0.5, enter down, and then the Y is the 6%, 6, enter down. And then the weight for, the weight for B would be 0.5, enter down, and then 7% enter down. And from here, you have all your data, and then you can ask for stat and then scroll back, use the up arrow. And you see that it's 6.5% is the weighted mean. That's the smallest I can get. So, okay. So if you didn't get that, no, here, okay, full screen. That's 6.5%. All right, so we've done the mean of two assets. Now, we haven't done this before. You should have learned this in your stats class, but it's possible you don't remember. Putting two variables together at a time and combining them to make a new one. So in fact, ERP is the expected return of RA plus RB. I didn't write that anywhere, but that's what we're doing. And you can't just, maybe I have to put the weights in, right? I'm going to rewrite this because it always goes over. So what we did was, I'll put it here. Calculate ERP equals to the expected return of XA RA plus XB RB. That's what we did. And this, so that the mean of a weighted sum of variables is equal to the weighted sum of their means. That's the property. So this is a rule of means that you should have learned. And if not, now you're learning it, okay? Well, so I've done the mean. That's the expected value. It's somewhere between the two of them because I've averaged them equally. Well, it would always be between them, right? If I do an average where the weights sum to 1, it should be between them. So it's exactly evenly between 6 and 7. So what about the standard deviation? That's the next part. What's the standard deviation of a sum of variables? Well, we're working with two assets. The formula for the variance of the return on the portfolio can be written like this. So that's the variance is the sigma squared of the portfolio. And this is the formula. So what we've done is we're calculating I'll do that again. That's what we're doing. We're taking the variance. Oops. Let me clean this up a bit. Just, nope. It's not helping me do this nice and neatly for some reason. I want that to look like an equals. Okay. So unlike the expected value, it's not simply the variance or the weight of the variance of A plus the weight times the variance of B. First off, there's another piece here. And second, it's not just the weight. I have to square the weight. Why is that? If you go back and you remember what I discussed, or you go and watch the statistics videos, you understand that the variance formula is computed by squaring the deviations from the mean, right? So squaring them, taking the variance of R and pre-weighting it, that weight will also be squared, right? So I have this part, the weight squared times the variance of A squared plus the weight squared times the variance of B squared, but there's this extra term. This extra term only exists if there's correlation there's a correlation between A and B. If they're unrelated, if there's no correlation, one doesn't depend on another, this does not exist. For instance, what if we're interested in combining a T-bill, which I explained has no variation, and asset A? So let's say asset B was actually a T-bill. In that case, there's no correlation because the T-bill, no matter what happens in the economy, the T-bill return, we assume, is constant and there's no variation, right? So there's no covariance in that case. And then that means this would be 0 and this term would disappear. So why I spent time studying statistics with you is because it'll be easy to know how to get this number, how to get that number, and how to get this value, okay? And also to understand why I'm using the Greek letters. I'm using the Greek letters because I gave you a distribution of the data that I treat like the population statistics, mu and sigma. Also implicit in the assumption is a symmetry of the data over time that allows me to use means and standard deviations as meaningful. Okay, no comments? Do you guys see my view? It looks like I have no view. Do you guys see that? Oh yeah, I don't know why it was not visible to me. All right. So this looks really intimidating, but it's not. It's just you need to practice putting this into Excel to calculate it. If we can do that, right? Let's do that together. I had some trouble with my Excel yesterday. Hopefully, I don't right now. So let me get the data set. This is basically my data. So getting the covariance first, that's really the most important thing, right? Because the weights are both 50% for our example. We know these already, the variance values. We've computed those already. All we really need is this covariance term. Yeah, something is up with my iPad. I think it's just the Excel software on here. It's like my keypad disconnected. Key, show keyboard. Just do it this way. Still, it's not working. What I'm going to do is reboot it. So what I want to put on this is okay, so I'm going to put up my probability. I'm going to put it in words. So the probabilities you go back to the data, we're like this, right? So going back to the original data, was 0.4, and for asset A, and B, you had 30%, and I'll stick with the, should I do that? And B is negative 20%. I think I need to make them decimals. So 0.3, negative 0.2. Now it thinks it's percentage. All right, it's fine. And then here is 60% chance in the second state, or the bus state, and that was negative 10% and 25%. So what I want to do to get the covariance is I need to get the deviation from the mean of each. So I have to return A minus the average return. The average return we figured out was 6. The average return for the weights that we used no, we have to use the return, okay, E of RA. I have to do the same thing for B. And I want to say this is of A. That looks confusing. I can't do subscripts in this Excel, so that's what you get. And then here it returns on B, right? Let's do that again. So essentially you can do this in Excel. And I did give you I gave you some exercises to do this, at least one. So you can put that information here as well. The return to A was, these are the averages here. All right, it wasn't R bar, but it's E bar. So this is going to be for A, if you remember, we got an expected return of 6%. And for B, it was an expected return of 7%. So you've got to calculate the deviation from the mean for A, the deviation of the mean for B, and then you have to multiply them and pre-multiply them by that weight. So this is it. Once you set it up, it's not a big deal. So you take return for A minus 6%. And the return for B minus 7%. And you have to square them, and no, you don't have to square them. You just have to multiply them to each other, right? So I'm going to copy this down. because it's the same. I'm hoping I do this right. And then you multiply. So I'm going to take the probability over here, and I'm going to multiply this and multiply. So the deviation from A's mean and the deviation from B's mean, and I do that. And then I copy that here, and then I sum them, and this should be my answer. So I'm just following along the formula you should practice to get that. I hope I got the number. Let me see. Yes, I got it. Okay, let's see if you solve that. So back to Excel. So that number is called the covariance. Can't write my nice notation here, but it's the sigma AB. And what did I do? The formula was I have to give myself a column. It was probability times returns of A minus the long I'm just repeating what I did. Then I did the same thing for B. This is all multiplied. So lots of writing just to explain to you what I did with those columns. And then I sum them to get the covariance. So that's the covariance of A and B. All right, so you should be able to reproduce that and get that result. The weighted covariance, the weighted variance, I'll see if I can figure that out on your calculator. Otherwise, just use Excel. Okay, we're past our time. So I'm going to pick up here next class. You can work ahead with the notes to see what comes next. All right, so we're going to calculate. I calculated the covariance, so I'm going to put that into the formula. So I did that, and I got the number. I think that's what I use. It's 0.0. There's a 0 there. And you put it all together with this formula, which is long. To avoid problems, you can use Excel, avoid making a mistake, and then you take the square root. And when you do that, you get this number. So we're going to end up talking about this. So hopefully finish the statistics review for next class, next week, and look at these notes and try and read through them completely so we can have a lively discussion next time. Have a good weekend. Bye.